Hello viewers, my name is Damilare. In this lesson we'll be looking at the topic copper. Copper is one of the first metals discovered and used by man. Copper is always found as ore, meaning you don't see it alone. It has to be with some impurities. And what are the ores? The first one, we have copper pyrite. That's CuFeS2. Copper pyrite. If you want to remember from the word pirates, maybe piracy, you now say confess. That means you should confess that this thing is a pirate. So confess, that's copper, iron, sulfur, that's the pyrite. Then another ore of copper, we have the malachite. That's copper trisulfide 4 and then copper hydroxide. So if you want to remember this, you pick the letter C to remember the carbonate, letter H, the hydroxide. So meaning once you remember the malachite, the CH is carbonate and hydroxide. So copper carbonate, copper hydroxide. Another ore of copper, we have chalcocite from chalcocite. So if you want to remember this chalcocite, the coke sounding k and the site sounding s, so meaning that k is copper, is sulfur, so copper sulfide, chalcocite. Another ore of copper is cuprite. Cuprite, that's copper 2 oxide. If you want to remember, just like write, when someone is writing 2, so copper 2 oxide. Now, how do we extract copper from its ore? Since it has impurities, how do we separate it from the impurities? The first thing is that there is a heating process strongly with silicon dioxide. Silicon dioxide is silica, that's your sand. So when you take the ore of that copper, that means any of the maybe copper pyrite, CuFeS2, so you heat that copper pyrite with silica, that's silicon oxide, and air, that's oxygen, in a furnace. Furnace is where you heat substances. Now there is a reduction process. The copper 2 ions that we have in chalcopyrite or copper pyrites, that's your ore now. So the copper 2 ions that is found there, it will be reduced to copper 1 sulfide. Remember, it is CuFeS2. So the S2 there, it will be reduced to S. That means from copper 2 to copper 1. So, and that is what we call a reduction process. Another thing is the copper sulfide, that's copper 1 sulfide, it will still be reduced again to copper, and that's the final stage. So this will still be explained using the chemical reaction. So don't forget, to extract iron, there should be a strong heating with silica. So there will be a strong heating with silica, and as I said, silica is the sand. So silica is the sand, silicon oxide, and there will also be air or oxygen for the burning. So, and when this takes place, there will now be a reduction from copper 2 to copper 1. From that copper, iron and sulfur. So where we have copper 2, so it will become copper 1. And finally, the copper 1 sulfide will become ordinary copper. So it's just like a 3-stage processes. Now, the iron in the chalcopyrite ends up converted into an iron 2 silicate, which we call slag. That means if we are using chalcopyrite where iron is involved, remember, look at it here, this is CuFe. So this Fe, it will later be removed as impurity in form of slag. So that's why I said from this copper iron 2 sulfide, it will later change to copper 1 sulfide and finally copper. But the iron that is there will be removed as slag, so which is an impurity. So from the slag which has been removed, so most of the sulfur in the chalcopyrite will later turn into sulfur dioxide gas. So this is used to make sulfuric acid. so via the contact process. So this is where everything takes place. Now this is your ore, the copper iron 2 sulfide, where the first thing that will happen to it is that there will be an addition of your silica, that's silicon oxide, and there will be addition of air, oxygen, for burning in the blast furnace. So the first thing is that from this copper iron 2 sulfide, it will be reduced to what? Copper 1 sulfide. It will be reduced to copper 1 sulfide, meaning that iron has been removed. So it is the iron that will now later mix with the silica, that silicon oxide, to form iron trioxosilicate, which is called slag, the one that will be melted and then removed as slag. So while the oxygen that is added to it will pick up the sulfur. Remember, the copper iron 2 sulfide has been reduced to copper 1 sulfide. So out of this 2 sulfide, one of the sulfur we add with oxygen to form sulfur 4 oxide, which will be removed as gas. Now the second process is that copper 1 sulfide will now finally be reduced to ordinary copper in the presence of that oxygen. So it means oxygen is to heat and also to help to take away impurities in form of gas. So it will take sulfur impurity to form sulfur oxide gas, which should be removed. Then the copper will be produced. So the end product of this is called blister copper, so which is a porous, brittle form of copper, and that's about 98 to 99.5% pure. So the next thing is, how do we purify copper? Now that the copper has been extracted, but there will still be impurities. So how do we remove the impurities? So from the purification of copper, when copper is made from sulfide ores, which we have done earlier. So when copper is made from sulfide ores by the first method we use, this is still impure. So that's why there should be a treatment. You have to treat it so that if there's any sulfur, because sulfur is always a great impurity, so if there's any sulfur that is still remaining there, so they have to trap it as bubbles of sulfur dioxide. So it means the sulfur that is in that ore, the sulfur that is there, so when you have made your copper but impure, since sulfur may still be found, so that sulfur that is still found there, you try to make sure you purify it by making sure oxygen is added to it to remove that sulfur in form of sulfur dioxide. So the copper that will now be formed there, they call it blister copper. So this blister copper, you will now let it undergo electrolysis, so whereby you cast it into anodes for refining using electrolysis. Now let's look at electrolytic refining. How do we refine this copper? The purification uses an electrolyte of copper 2 sulfate solution, meaning you take your electrolyte copper 2 sulfate solution, you bring the impure copper you have extracted from the previous explanation, that at the end you have your copper but the copper is still impure. So that impure copper, you will now use it to form anode. So if this is where your copper sulfate is, remember the copper sulfate will represent the electrolyte. So if this is where the copper sulfate is, which is electrolyte, then there will be an anode here. So an anode is a positive electrode. So that anode, that is where you have your impure copper. So let's take it as zigzag. So you have your impure copper. Then at the cathode here, you now have your pure copper. So this is the negative electrode called cathode. So you have your pure copper there. Now what will happen is that to have a pure copper, so what will happen, okay, even this is the drawing we can use, but this time they put the anode on the right, they now put the cathode on the left, and you can see this dot representing that the copper is impure and the copper sulfate is still intact here. Now how does this happen? At the cathode, that's looking at the one on the left, the pure copper, remember that anode is where electron leaves. That means electron always leave or go out, so electron is lost at the anode, and that's what we call oxidation. But here at the cathode, that's where electron is gained. So there is electron gain at the cathode, and that's what we call reduction. Now let's now see how this takes place. Don't forget, our focus is how to purify our copper through electrolysis. So at the cathode, the copper 2 ions are deposited as copper. Let's look at cathode. So they say at this cathode, the place where electron is always being gained. Electron is always being gained. So they said copper 2 ions are deposited there. So that means gaining, deposited, gaining, deposited, meaning that copper will be coming there. Copper will be coming there, meaning that it's gaining that copper 2 ion. So it will be gaining. Its own is to be gaining. So this arrow shows that it's gaining copper 2 ion. So, and from this reaction here, anything that is together on the left, that shows that there is a gain. But if this 2E minus, if it's written on this side, it means it's losing it. So mean that the cathode, there is a gain of electron by the copper 2 ion that is there. Remember, copper 2 ion will be there waiting at the cathode when this splits, when there is splitting of copper and sulfate. So copper will migrate to this place because cation, so from cat, the cation of copper will come to the cathode, so it will come and stay there. So, and that's where it is deposited. So we say at the cathode, copper 2 ion is deposited. That means where electron is being gained. And once that takes place, as it's being deposited there will be more copper. That means this thing will be getting fatter. This electrode you are seeing, it will be getting fatter because copper will be added to it. It will be gaining copper. Copper will be added. Okay, on the other side, which is anode, copper goes into solution. Copper goes into solution as copper 2 ions. Remember that electron is always being lost here. So meaning that any copper that is here, remember this rod is made of copper, but its own copper is impure. So meaning that all the impure copper, they will start going down. It's just like something that is eroding, or that is just that is defoliating. That means peeling, like something that is peeling, or rusting that is peeling. So that peeling copper, which is impure, it will begin to go down into the solution. The copper will start going down into the solution. So that is what happens at the anode. And as I said, when it is on the right, it shows it's losing, it's going out. So loss of the copper 2 electron shows that it is going into the solution, so as copper. Now that tells us that what will now begin to happen to this impure anode, it will begin to reduce. It will begin to reduce. Remember, it was impure, it will be reducing. But here, this one that was pure, that means the pure will be increasing, pure will be increasing, impure will be decreasing. It's just like recycling. When you are taking something that is dirty, maybe iron that is condemned, so the condemned iron will be reducing, while pure iron will be increasing at the end. So, and that is how that's what they call purification of copper by electrolysis. Now, the conclusion is that for every copper ion that is deposited at the cathode, in principle, another one goes into solution at the anode. So concentration of the solution should stay the same. What are they saying? So it means concentration of the copper here will be the same. Why? Because if, let's assume, 5 of copper is released into the solution, 5 will go back into this cathode. If another one comes down, it will also go back here. So meaning that not as if the concentration of this one will increase, it's not going to increase, it will remain the same. So all that happens is that there is a transfer of copper from the anode to the cathode, meaning that everything that is happening here is that this copper impure is coming out from anode, coming to the pure as cathode. Another thing we'll be looking at, so and I said, okay, from the anode to the cathode will be getting bigger. I've said all those things. As more and more pure copper is deposited, so it means what is coming to that other side is that the copper will be getting bigger. So while the anode, it will be gradually disappearing. That means the impure disappears, the pure appears. Now let's look at physical properties of copper. When we say physical properties, that means when you say copper, physical, what are the characteristics? It's heavy. Remember, it's a metal. It's reddish brown. just like all this copper wire that they use, all this generator engineers. So you see the color reddish brown. It's very malleable. General characteristics of metals: malleable, that means it can be hammered, you can break it, you can hammer it, bend it. It's ductile, you can draw it into wire, and that's why we have copper wire. It has density of 8.95, that means it's heavy, gram per cm cube. Is a good conductor of heat and electricity. So since it's a metal, electricity and heat can pass through it. It has high melting point, meaning that before it melts, it takes a long period of time, 1083 degrees centigrade. It has a BP of 2300 before it gets boils. Then it can form alloy. You know, there are different alloy of copper, from brass, copper and zinc. So that's alloy. They come together to make that metal harder. Also bronze. Bronze is copper and tin, also to make it stronger. So and so on. Now, what are now the chemical properties of copper? Meaning that when you add copper with some chemical substances, what will happen? So we can react it with air, that's oxygen. So when we react it with air, then what will happen on heating in air oxygen, copper is readily oxidized. So it means copper can be oxidized with oxygen, and once it's oxidized, the copper becomes black. That's copper 2 oxide. So black copper 2 oxide. So that's number one chemical property. Out of effect of acid, when you throw copper in acid, what will happen? Normally metal in acid is supposed to liberate hydrogen gas, but not like that of copper, because in terms of the position, there is a particular mnemonic I always do that says Zachariah is too lazy. How can my sister go? So meaning that from the electrochemical series, after zinc, iron, tin, lead, hydrogen, then copper, meaning that hydrogen comes before copper. So meaning that it is hydrogen that has the power of removing copper. Copper does not have the power of removing or displacing hydrogen. So that's why in acid, so the copper does not have the power to displace of hydrogen. So it is, however, but the only thing that will happen is that that acid will attack that it will attack the copper. So it will attack the copper. That's especially the acid that is an oxidizing acid, like trioxynitrate 5 and tetroxophase 6. That means the HNO3 and then the H2SO4. They are the ones that can attack copper, being an oxidizing agent. So let's see how they do the attacking. Now from here, look at this HNO3. That means it's an oxidizing agent. There are a lot of oxygen there, 3 oxygen. One of the oxygen we join with nitrogen to give us nitrogen 2 oxide. The same oxygen again we join with hydrogen to form water. Then the third oxygen we now join with the 3 of them. The third oxygen we join with the N, and then pick this copper with it. That's copper nitrate. So that is how it operates. You can see that you do not see anything like hydrogen gas being displaced off. So that is how it can attack. Oxidized agent can attack it. Then displacement reaction. So if you compare copper with another elements, so other elements like iron, they can displace copper. From that, Zachariah is too lazy. How can my sister go? So if you compare iron, so see where iron is. You know, it says Zachariah is. That is means for iron. Then look at copper. Too lazy. How can? So from copper is far, meaning that iron can displace copper, and that's why from iron here, it can displace copper from copper sulfate, and it will give you iron 2 sulfate. That's another chemical properties of copper. Copper can be displaced by iron, which is higher than it, because iron is higher than copper in the electrochemical series. It can be displaced by the hydrogen gas. It can also reduce copper oxide. Since hydrogen is also higher than copper, it can still remove copper and then take it up. So hydrogen will take the oxygen, and then copper will be displaced. So meaning that it's still talking about displacement. Now, how do we test for copper 2 ions? Just take sodium hydroxide. When you add few drops of sodium hydroxide solution, add it to the copper salt. Get a copper salt. So add that sodium hydroxide, So you will notice a blue color, so a blue precipitates, and that blue will be insoluble. That means it will not dissolve. In excess sodium hydroxide, we pour enough sodium hydroxide, it will not dissolve. So, and that is proving what? The presence of copper 2 ion. So this is the copper 2 ion, that means the copper salt, and this is the sodium hydroxide you are adding. So the blue you will see is the copper hydroxide. Then that's copper 2 hydroxide. So then sodium will be alone. Now what do we use copper for? Amongst other things, copper is used for electrical wiring. Remember, it can conduct electricity, so it's for electrical wiring. Also domestic plumbing, all these plumber, those that are doing pipes, so they make sure the copper, they can also make use of copper in making their plumbing materials. Why? Because since if water is passing through all this plumbing material, so it can't affect copper. And again, you can easily bend copper, so that's why it's good for plumbing material. Also has a boiler, maybe all this boiling ring, so you see that they can use copper to make boiling ring because it can conduct electricity and exchange heat. So, and water cannot affect copper, so it can be put inside water. Then baking brass, so you can use copper as a brass, that means to make your metal stronger. So like brass now is copper zinc alloy, that means you join copper with zinc, so that's brass to make it stronger, that means harder. The same way for bronze, you can take copper with tin, so that's another usefulness of copper. Coinage, you can use copper to make coin. There are some coin that we call them copper colored coins. Some of them they are silver coins. So some they use nickel, added nickel to them. So like we have copper nickel, you add copper and nickel together to make the coin. All these euro coin, UK pound coins, so they added copper to them, zinc, nickel coin. So that is for the copper. So thanks for listening.